So let's discuss about the dynamic memory allocation. In dynamic memory allocation, something called as Malloc and Calloc, which we'll be going to discuss today, and realloc in the next session, and as well as a free also. Whereas Malloc and Calloc, as I mentioned, that I have mentioned something called as here. You can see it something like this: int a is equal to 10. When you tell it int a is equal to 10, there is you know what? Okay, it will go to the memory location and it will create a block of memory of so many bytes, and it will return the address and it is storing this 10 and so. Okay, my question was something like this: who is actually is the reason to create this memory, correct, right? So there comes your Malloc and Calloc. Okay, these two fellows are the reason to create this memory create this memory. Okay, now coming to this, how it is like Malloc is something like this. Okay, Malloc is a method which is actually in the stdlib, and Calloc is also in the stdlib. There is a slight difference between the Malloc and Calloc, as I mentioned. Like Malloc is a method which, as I told you, like a shopkeeper's example. If I tell you, as I get a chocolate, what you will do it? Okay, you will see my face, correct, right? And you tell it how many chocolates I want to get it, correct, right? Again, I want to give the money also, so that is the other thing. Okay, so now coming to this Malloc, like same thing. Malloc will be seeing my face. Okay, bro, how many bytes I want to create it? Okay, so I need to specify it. Bro, you create 2 bytes. Go and it will create 2 bytes and will return the address. Okay, same thing. I can give it any number of. If you want to create 20 bytes, it will create 20 bytes. If you want to create 40 bytes, it will create 40, 100, 200, whatever the bytes you want to create it will create it. Nothing to worry about it. Okay, now there is a slight difference between a Malloc and Calloc. Malloc allocates has a 1 argument, whereas Calloc has a 2 arguments. When it comes to the Calloc, I will tell you what is that 2 arguments. Okay, whereas Malloc is nothing but entire block. It will create at a one shot. It will create a block. It is nothing but a memory allocation. It will create an entire block and will return the address. Calloc is something like this. It will create a memory in the contagious memory allocation. Okay, when you are creating a memory by using a Malloc, guys, when you're creating a memory using a Malloc, this can be seen in Turbo C++. Okay, when you're creating a memory using a Malloc. Okay, so it has something called as a garbage value. If you don't initialize the memory, it has a garbage value. Okay, whereas Calloc, it has a default value called as 0. For each contagious block it we allocate, it has 0 as a default value. Okay, so this is the one thing. And one other one thing is, like, it has a single argument and it has a 2 arguments. I will be discussing further. Just so much you remember it. Malloc is a method which is in the stdlib.h header file. If you want to use this Malloc and Calloc, you need to use this header file. Malloc is the reason to create a memory dynamically, or to allocate a memory, whatever it is, to allocate a memory. If you're using int a is equal to 10 is also, it is defaultly, it is invoking a Malloc method, and it is helping you to create this memory, and this address is returned. Okay, Malloc job is to create a memory, to reserve a memory and to return the address. To create a memory and return the address. Create a memory, return the address. Create a memory, return the address. The number of blocks you need to mention it. Okay, now let's discuss about the Malloc, guys. Let's discuss about the Malloc. What are all the things you can come up with that? It is linked to the last previous topic. Okay, how the Malloc is designed. Okay, you have a Malloc method. When it is coming to the method, you need to open and close the parenthesis. Okay, as I told you, I want to specify the size. I want to give one argument called as size. Okay, I'll send the size. Okay, that will be in the integer type itself, not to worry about it. Okay, they have some similar kind of structure type. To go into the more details, you have the struct. They are using it by their own data type, and they are dealing with that. Not to worry about it, but it is a type of integer itself. Okay, so at the end of the thing. Okay, Malloc, if I tell it as 4 bytes, it will go and it will create the 4 bytes. And what it is, Malloc is returning what? Address. That means this Malloc is a returning address. That means I want to write it as what? Address type. Okay, now my question is, which type of address it will return it? Correct, right? Which type of address it is returning it? Okay, whether it is returning integer type, whether it is returning float type, double type, character type, structure type, union type. Okay, I don't know which type it is. Okay, very good. It will return which type? Void type. Why void type? Because it is a generalization form. Okay, Malloc will return void type, user, whatever you wanted it. Later in further, you can typecast it. Okay, this is the answer I was expecting it. Good, Shiva. Okay, so which type it will return it? It will return it void type. You got the clear picture of the void thing, why I was explaining it. Okay, just to form the generalization form. Just imagine guys, if you don't have this void type, now you need to have n number of malloc, malloc 1, malloc 2, malloc 3 for everything, for integer 1 malloc, for character 1 malloc, for float 1 malloc. Okay, everything is recovered by this void type. This void is very, 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 very important data type. At the beginning of the class, I told you, I asked you question, which data type is very important. Okay, so you came up with a many answer, but as per I know it, this void is like a very, very, very essential data type. Okay, if it is 0 also, it acts like anything. Okay, now what is it happening? Malloc will return it. Malloc will return, malloc will go first, it will go and will create the memory, so many number you have passed it, whatever the size you have passing it, and after creating a memory, it will return the initial address. It will return the initial address. That initial address will be which type? Void type. In the further case, you can what you can do it, you can typecast it for whatever you wanted it. Okay, that is what we are looking onto it. Okay, there is one thing guys, there is one thing you need to understand it. Okay, so there are two possibilities which is returning it. There are two good question you asked this, Shiva. Okay, there are two possibilities it will return it. First return is, for the first case return is, if it is successfully creating a memory, it will return the address. Okay, successfully, on success, it will return what? It will return on success, it will create, it will return what? RETO, return what? Return address. On success, it will return address. Else it will return RETORN, return 0. Okay, if the memory is not created, if memory is not created means if you are sending 0 bytes, okay, it will return 0. If your machine doesn't have enough space to create such a big amount of memory, it will return again the 0. So one case of creating a memory is int a is equal to 10. You know all about this, correct, right? Int a is equal to 10, and you will tell it, okay, print f, I will tell it has percentage d, and you will tell it has a, and it is printing what? 10. Absolutely no doubt in this, correct, right? It is very simple program and absolutely no doubt on this. Okay, now without using this int a is equal to 10, with the help of malloc and calloc, I'll be creating a program. I'll be writing a program on this. Okay, so hash include stdio.h, and int main you have it, and you have something called as int a is equal to 10. You know all about this, correct, right? Int a is equal to 10. It will go and will create a memory and store 10, and it will return the address. If you use a, it will give the output as 10. No problem with that, correct, right? And I am telling you who is actually helping for this int a is equal to 10. It is nothing but malloc. Okay, now without using this line, I'll be creating a same memory by using what? Malloc and calloc. Okay, by using a malloc. First we look onto the malloc. And later we'll be looking onto the other things. Okay, now how to use that? Okay, so what I need to do it, I need to use a method called as malloc. Are you agree with this? I will be using with the malloc. Okay, I want to, this is a malloc method. I'm calling this malloc method, correct, right? I'm calling this malloc method. Okay, now I'll be showing you some errors, guys. This is very important. I'll be showing this errors, some errors. Okay, before errors. Okay, I want to, again, I will get it on this line also. I'll get it error. I don't want to get it now itself. Okay, now I'll be showing some warnings or errors. We can look onto it. Okay, so cc pgm1.c, and you can see this warning, guys. Okay, look on this. Implicitly declaring library function malloc with the type void star unsigned long. Okay, whatever it is. Okay, malloc. Okay, you have a first warning, and you have something called as another warning. Too few arguments to a function call. Expected 1, have 0. That means I'm writing a program, I'm using a malloc method, but I'm not passing any arguments. Expected how much arguments? 1 argument. That means in the declaration part, okay, when they have developed that, okay, they have passed how many arguments? 1 argument. I want to compulsorily pass 1 argument. Okay, that is what the error I am getting it. And warnings, what I am getting it, I am getting the warning, something called as other one thing, you note it down, this one. I should include the header file called as stdlib.h, or explicitly provide declaration for the malloc. Okay, I want to use this header file, or else the compiler, in this compiler, it will explicitly provide it, nothing to worry about it. when you are using it, this malloc is present in which header file, guys? stdlib.h. That is what you need to know. First thing is, how many arguments? One argument, expected one argument. Other one thing is, it is actually in the form in the header file called as stdlib.h. Done with this? Now I'll be going for the I'll be going to the program. I'll be going to the program. So what I need to use it? First thing I need to use it is I need to use the header file. What is the header file? Hash include. I need to use it stdlib.h. Okay, I'll be using this header file. Okay, now I'm using this header file. I'll tell it I need to pass the argument. What is the argument? I'll pass it. I'll tell it as 4 bytes. I'll tell it as what? How many bytes? 4 bytes. Okay, now this method is actually returning something. So what is it returning? I told you guys, I had told you it will return what? Address format specifier is what? %p. Okay, so I will tell you it will create a 4 bytes. It will create a 4 bytes. Malloc is invoked. It will create a 4 bytes. After create, it will go and create a 4 bytes of memory, and it will return what? Initial address. Okay, so let's see it. What it will return it. Let's see it. What it will return it. I'll tell it has clear. I'll tell it has clear. Okay, so I'll tell it has ccpgm1.c. I'll tell it has /a.oyot out. Okay, now you can see this. It is returning what? The malloc is returning what? Initial address. It is created the 4 bytes of memory, and it is reserving. Okay, it is reserving. Already there is a memory. It is just reserving this memory. I'll be using this memory. Okay, it is nothing but it is constructing a compound in the memory. In future, no one should come and attack to this memory. Okay, that is what it is. Okay, it will reserve 4 bytes of memory, and it is returning the initial address. And this address, which type, guys? This address will be in the type of called as void star. Okay, that is what you need to remember it. That is what the important thing. The address type is what? Void star. Okay, and you know how to convert from void star to whatever the star is. Correct, right? Okay, now looking onto this, guys, this line, since it is returning the address, I will be storing this address in one memory location. I will be storing this address in the one memory location. For example, I am calling this method malloc, and I am passing something called as 4. Okay, I can passing something called as 4. Or else, instead of this 4, can I tell it has something like this, guys? Size of integer. Can I write it like this? It's one and the same. Correct, right? Size of integer. What is the size of integer? Will return it. Size of integer will return it something like this. Size of integer is nothing but what? 4 bytes. Correct, right? So for example, if you want to see it, I will show it also. Like size of, it has integer. If it has size of integer, I'll come here, and size of integer return type is an integer type. So I'll do it as %d, and I'll compile this, and I'll go here. 99999. I didn't write it this one semicolon. Gosh. Okay, so I'll come here, and I will be writing it as what? Semicolon here. Nothing to worry about it. So shift colon bq. I'll be coming here, and warning. Not to worry about it. /a.oyot out, and it is returning how many bytes, guys? You can see in this corner it is returning how many bytes? 4 bytes. Okay, it's returning how many bytes? /e.oyot out. It is returning how many bytes? 4 bytes. So I'll go for the program. One and the same. Either I can write as size of integer, either I can write as just a normal as 4 itself. Nothing to worry about it. Okay, and you need to remember this malloc is returning what, guys? Initial address. Okay, so I'm returning this 4, guys. I want to, this malloc is returning something. Correct, right? This malloc is returning something. I want to store it in one variable. I will tell it as whatever the variable is. I will tell it as a. Okay, now I want to declare a, guys. Now I want to declare what? A. Okay, I want to declare a. What a is storing, guys? What I am storing inside a? Whatever the malloc is returning. What malloc is returning it? Malloc is returning address. Okay, do you have address data type? No, you don't have address data type. So what will you use it? You will use it a special character called as what? Star. Okay, now I am telling which type of address this a should store. User needs integer type of address now. User needs what? Integer type of address. Okay, if user needs character, user can do it as character. If user need float, you can do it float. User need double, you can do it double. Okay, now what I'm doing, what I'm trying to tell you is, like, this one is returning void type. Okay, and I'm storing it in the integer type. Okay, mismatch, type mismatch. What I need to do it, I want to do it typecast. Okay, what if I do this? What if I do this? Let's check it out. Okay, what if I do this? Let's check it out on this. Okay, what happens if I don't typecast it? What happens if I don't typecast it? So if I come here, I will tell it as a warning. Format specifier type int, but argument type has unsigned along. Okay, okay, I will come in this line. Okay, I will run this, and again I will tell it as cc. Okay, no compile time error. I will tell this dot a dot out out. Okay, no runtime error also, nothing to worry about it. It's not showing it, but it will show the error called as type mismatching error. It is resolving it in implicitly, not to worry about it. Okay, what is the error you are getting is, it is a void star and you convert it into int star. It cannot be possible. So what I need to do it, guys, I want to typecast it. Okay, that is what I want you to explain it. So int, I want to convert this address to integer. I want to convert this address to integer. Has we done it before? Okay, has we done it before? Okay, so if I tell it as a, inside a I have a address, correct, right? Inside a I have a address. Do you remember when I took the array class, you have a address? Okay, you want to store something in that. Okay, what do you, how do you store it? You will tell it as a is nothing but address. You need to go inside. Now knock knock, correct, right? So what I need to use it for knock knock, I will be using what? Star. Okay, I'll be using it what now? I'll be telling it as what? 20. Okay, now if I come here, okay, if I come here, understand this. If I tell it as percentage p, and I will tell it as percentage d. Okay, so first thing I will tell it as just a is nothing but an address, and the next one I will let as star a. Okay, so what I will do it, I will remove this comment, escape shift colon wq. I'll go for this one, compile it, and I will tell it as dot slash a dot out. And you can see this, guys, you can see this. Here you have address of a, you have address of a here, and you have 20 as a value. Okay, so if you need to have a clear known thing, malloc is a method. It will go and create 4 bytes of memory. It will return the address. The address will be in the void star. I'm typecasting into int star, and I'm storing into the a. Now what I do it, a has an initial address. I want to store inside that 20. So what I'll do it, star a I will do it, and I will do it as 20 here, correct, right? So if I do it as star p percentage d a is nothing but address, and star a is nothing but a. You can take it down. If you have any queries, you can comment on this. Okay, here I have not used anything else. Here I have used one variable to store the address, not the value. So can we check the size of memory block of a FE? Okay, yeah, you can check it out, but a is actually storing address, and the size of address according to my machine, it will return you 8 bytes because it is an address. In Turbo C++, you will get it 2 bytes. In other compiler, you will get it 4 bytes. In online compiler also, you will get it 8 bytes, because a is just a variable holding an initial address. That's it. Okay, guys, upon this question, I will just explain this out of thing question. Okay, look onto this, guys. Okay, ये क्या होता है initial address का क्या होता है? Okay, if you know the initial address, you can access remaining address frequently. Okay, that is what the leakage comes. Okay, this dynamic memory allocation has something called as a memory leakage concept. Okay, I will explain you what is that leakage concepts. Okay, now coming to this, guys, as I am reserved only 4 bytes, correct, right? Other bytes I can access it, but it is not reserved. Okay, that memory can be overridden at any time, any point of time. For example, guys, what I will do is, I know something like this. Star a is nothing but a initial address, correct, right? If I tell +1, guys, what will happen? Correct, right? The question comes here, correct, right? It will happen something like this. A means initial address, +1 means it will go and check the type. What is the type? Integer type, correct, right? It will increment by 4 bytes now, correct, right? Same thing, similar to arrays now, correct, right? Now I will be going inside now. I'll be going inside now. I'll put it as star. Is that correct? No, it is not correct. Why? Because the star will get access first. Correct, right? So what I need to do it, I need to apply something called as board mass rule. I'll apply the board mass rule and I will save it what? I'll tell it as 40 now. Correct, right? Now what I can do it, I can access this one percentage D here. This becomes allocation of contiguous memory allocation. Correct, right? So if I tell it has a plus 1, if I tell it as a plus 1, if I tell it as a plus 1, and if I allow it has a plus 1, and I'll tell it as star. Correct, right? This will return me 21. This will return me 21 if I am not putting the board mass rule. If I put it board mass rule, what happens now? I'll tell that solve this first, and now it will give me the 40 thing. Correct, right? So if I go for this one, I'll compile this. I'll let us /a.out. Now you have something called as initial address. You have it, and then you have it 20. Then you have it 40. Okay. For furthermore, if you need to check it out, the address of this one. So what I'll do it now here. I will come here. Now what I'll do is I will also check it out the address of this one. How many bytes it has incremented. Correct, right? So I'll tell it as a plus 1. Correct, right? So I'll come here. You can just check it out here. Okay. So I'll come here, compile it, and I will run this program. Look on this, guys. 60. Correct, right? The initial address is 60. The next address is what? 64. From there, and another one memory is also allocated. Like that is. For further, after this, you can access any memory. This concept is called as memory leakage now. Okay, and this memory is not reserved. From this memory is not reserved. Okay, no matter in future, anyone can come and attack it. Why? Malloc is not responsible for that. Malloc is only responsible for this. Malloc is only responsible for this 4 bytes. Okay, Malloc is not responsible for any other things. Okay, Malloc, if I write it as Malloc of 8, if I tell it as Malloc of 8, okay, then I compile it, then it is responsible for both memories. Then I can responsible for. Even you can write it in the Malloc something called as 1 also. You can write 1 also, but Malloc is only responsible for 1 byte. Okay, in future, okay, मेरा पैसे उड़ गए, मेरे पता नहीं, मेरे place था ये, कोई और आ गया. Malloc is not responsible for that. Why? You have reserved only 1 byte. Okay, and you have returned the address to A. Okay, from A you are accessing all those things. This drama never works. You need to reserve the memory for this one. Like this.